In a recent video, I demonstrated how to solve for the coefficients a, b, and c of a parabolic or quadratic equation of the form ax squared plus bx plus c, and then if we set that equal to 0. And it didn't feel right to not discuss the tried and true go-to solver, the quadratic formula. Which states that the two solutions, x1 and x2, for given a, b, and c are negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a. But how do we know we can trust the quadratic formula? Let's take it step by step to see how the quadratic formula is derived. We'll start by adding a negative c to both sides. Then let's get the x squared term by itself, dividing everything by a. Now we can complete the square on the left-hand side of our equation, adding the quantity b over 2a all squared to both sides. Now that we have our term in place to complete the square, we'll go ahead and complete the square on the left-hand side. Let's go ahead and simplify that right-hand side a little bit. So to get common denominators, I'll have to multiply by 4a. Now with the left-hand side completed, oops, can't forget all of those implications. Now with the left-hand side square completed, go ahead and take the square root of the left and right-hand sides. So we'll have plus or minus the square root of b squared minus 4a, oops, I had forgotten a c, all over the common denominator 4a squared. So that implies that x1 or x2 is equal to negative b over 2a plus or minus the square root of the quantity b squared minus 4ac over, 4a squared can be simplified under the square root as 2a. We already have common denominators, may as well simplify. And there you have it, a proof of the quadratic formula.